Today we're going to talk about adding and subtracting polynomials today. Which one do I like better though?
Adding.
That's right. Because if you have subtracting polynomials, you could always change them into?
Addition.
Correct. That's right. Adding the opposite. Very good. So I'm going to, before I talk about adding and subtracting polynomials, okay, I want to talk about I want to show you some vocabulary that you should know. Okay, monomials. Anybody know what monomials are? Give me an example of a monomial.
Oh, it's
Samuel? 5. Yes, 5 itself is a monomial. It's just a number, but you could actually call that a monomial. Yes, Chuck?
like A.
Sure. If you have a by itself as a monomial, yes, sir. 5x, that's a monomial. Yes. 3x plus 2. That will not be a monomial. That's called something else. That's called a binomial. Good. We're going to talk about that in a minute. What about this? Negative 7xy. Is that a monomial?
Yeah.
Yes, it is. So here's some examples. And this is the definition of monomial. It has, how many terms does it have? One term. By the way, here's a fact. You should write this down. Terms are separated by, anybody know? Addition sign is correct. So look at all these monomials. Do you see any addition involved anywhere in each of these monomials? Do you see any addition? No. Therefore, how many terms we have?
1.
Okay. Therefore, this is the reason why it's called monomial, because have you guys heard of monorail before?
Yeah.
What does that mean?
Like
One rail, right? So monomial, one term. Okay. So here's actually definition. Okay. So this is how you define monomial. Your book defines it this way. Monomial is an expression that is either a numeral. What do you think that means? A number, a variable, or product of a numeral and one or more variables. So that's the definition. So monomial is basically a number, a variable, or product of numbers and variables. Okay. And as you can see, there are examples. So I'll wait for you to write this down. Any question, by the way? Yeah, I'll wait. I'm asking you to change that to number. Okay, so it's the same thing. So either a number, a variable, or product of a number and one or more variables. Okay. So anybody need more time?
I do.
Oh, okay. Take it. So if monomials are what we just described, can somebody how many terms does monomial have? Mono means one. Can somebody guess if I were to have two terms? What do you think this is called? If one term is called monomial, if you have two terms, yes sir. How many people agree with them? Binomial. Okay, is this correct? You're right. Binomial. Then you have two terms. As you can see, what separates the terms again? Addition sign. So you get 2y plus 4w. That's an example of a binomial. Then, can somebody guess what we call these expressions if you have three terms? Three terms.
Oh.
Three terms. Okay, raise your hand if you think. How about, yes, over here, Lindsay? Trinomial is correct. What does that remind you of? Like tricycle or triangle? Sure. Tri means three. So that's easy, right? Again, what separates these terms? Addition sign. So there are three terms, as you can see. Does that make sense? Okay.
What about 4?
Okay, so we don't really have name for 4. It's not quadromial. No, we don't have that. We just say this. If it has 4 terms, we say this is a polynomial. Very good. Polynomial. By the way, what's a polynomial then? Yes.
Anything that has terms.
That's exactly right. So it turns out it's basically sum of monomials. Okay, so that's one nice way to put it. Sum of monomial is called a polynomial. And so Jason, if you have 4 terms, then you say it's a polynomial with 4 terms. Okay, so we have a name for 1 term, 2 term, 3 term. We don't really have a name for 4 terms or anything. So we just say a polynomial. Okay, so, oops. Polynomial. Okay. Any question? Does that make sense? All right. Yes.
When it's just sum of monomial is called a polynomial. Is this the same for like other two?
Yeah, so binomial is a polynomial. Also, trinomial is a polynomial. It's just we have a special name for those. If it has one term, it's called monomial. Two terms, binomial. Three terms, a trinomial. But they're all polynomials. Okay, very good. Now, we just said terms are separated by addition sign, right? By an addition sign. So what about this? How many terms does this have? Think about it. Everybody write this down. And write down how many terms you think it this 2x minus 5 have. Okay, go ahead. So with your fingers, tell me how many terms you see. 1, 2, 3, 4, 5. Okay. I want 100% participation. So I have 2 minus 5. And what we just said here, terms are separated by an addition sign, right? So some people have 1. Okay, some people have 2. Very good. Okay, what? So for those of you that said 1, why did you say 1, Chuck?
Because it does not have an addition.
Yeah, I don't see any addition sign, right? But there are a whole bunch of people that show me that there are 2 terms. Okay, Kyle, what do you think? I mean, Aiden.
Because 2x minus 5 is the same as 2x plus -5.
Thank you. Remember, subtraction really means what? Adding the. So therefore, you could actually think of it this way. So, how many terms does it have, class, Willie? 2. Okay, so please, this subtraction is a sort of a shortcut, right? 2x minus 5. So even though you don't see any addition symbol, there addition is right there actually. It's sort of hidden. Does that make sense? So it has 2 terms. Now, then what are these 2 terms? Who could tell me? So it has 2 terms. The 2 terms are what? Chuck?
2x and 5.
How many people say it's 2x and 5? Raise your hand.
Oh, wait, no.
Oh, you want to change your mind?
Yeah, 2x and negative
It's
5.
2x and negative 5. Do you see why I like to change things into addition? Because once you change things into addition, you can see the terms clearly, right? Do you see if I were to leave it as 2x minus 5, you may think, oh, 2x and 5 are the terms. No, terms are separated by an addition sign, right? Therefore, once you change it to an addition, you can see that the terms are what the terms are clearly. Somebody had a question?
Yeah.
Yes, sir.
This can be like this.
Yeah, so something like this, they could ask you, they could say, what are the terms, right? Then you have to tell me correctly, the terms are 2x and negative 5. If you said 2x and 5, it'd be wrong. Okay. Any other question? Are we good? All right, let's move on then. So if I have 2x by itself, what is this, guys? What is this expression called? Yes, sir. Monomial, very good. Now in this monomial, we have the number 2 in front of the x. What is 2 doing to x? 2 is multiplying the x. There is a special name for a number that is multiplying the variable in a monomial. Anybody know what that number is called? It starts with C. And it sounds really hard, but it's not really. Christina? Constant? Okay, yeah, a number you could sometimes is called a constant, but if a constant number is multiplying a variable like this, it has a special name. And it sounds real hard, but it's not really. It's just basically a number multiplying the variable. Patty? How many people agree with Patty?
I do.
Okay. Joseph, you agree with Patty? She is. You guys are correct. It's called a coefficient. And coefficient sounds real hard, doesn't it? But it's nothing more than a number what? Multiplying the variable. It's the number. Multiplying the variable is called a coefficient. So I'll be referring to these as coefficient, and you should know what I mean by that, right? Okay. Go ahead and write it down. I'll wait. So how many people have heard of similar terms or like terms before? Very good. Does anybody know what they are? So when we're talking about polynomials, we talk about this a lot. Similar terms or like terms. Yes, sir. What do you think similar terms or like terms are? The same thing. What,
Like 5x and 2x.
good. That's a very good example. 5x and 2x are like terms, aren't they? Can somebody give me another example of similar terms? Claire? Oh,
2W and 10W.
sure. 2W and 10W. What about 2W and 2W? Are they like terms? Yeah. So they could have same coefficient or different coefficient. It doesn't matter. And they have to have the same variable, right? So what about this? Let me give you an example. Oh, you want to give me another example? Go ahead.
J and negative J.
J and negative J are like terms. What about this? X and x squared. Well, they have the same variables, don't they? So how many people say yes? Raise your hand. X and x squared. Are they like terms? They're not like terms, turns out. Even though they have the same variable. So to describe like terms, can you say, oh, these are terms that have the same variables? Would that be correct? No, because if I say x and x squared, they have the same variable, but they're not like terms, are they? So how would you describe like terms? Anybody? Yes.
I have a question.
Question.
Like I know if you're like combining it like x squared plus x, you can do it. If you do x squared times x, would be x.
Yeah. So we'll talk about that later. Yeah, we're talking about first of all today's topic, adding polynomials, right? So when you multiply, yeah, you don't have to have like terms. When you're adding or subtracting, you need like terms. Okay, so who could describe for us what like terms are? Okay, Dana? Say it again. When the coefficients have the same variables after. Okay. Patty, did you want to ask something? They have to have the same exponent. So what about x squared and y squared? Oh, they have to have the same variable and the same exponent. Okay. What about their coefficients? Do they have to be the same or different or?
They can be different.
It doesn't matter. They could be same or different. So here, very good. I think you guys have the idea. Here's the definition. These are two monomials. So if we're talking about like terms, these are two monomials that happens to have that are exactly alike, except for their what?
Coefficient.
Exactly right. Except for their coefficient. So here's some examples. Like 3x and 3x. Okay. Here, 7y and 4y. They don't have to have the same variable. Okay. So write that down. I'll wait. So like terms or similar terms, when we talk about like terms or similar terms, we mean that these monomials, these are two monomials that look exactly like, except for their coefficient. Okay. So write that down. How about, look at these two terms, 3xyz and yxz. Okay. Are these, oops, sorry, you can't see. Are these like terms? 3xyz and then yxz?
No.
How many people think no? Raise your hand. How many people think yes, they are like terms? Okay, turns out these are like terms. But you may say, wait a minute, yeah, right. They don't look alike, right?
Yeah.
They don't look exactly alike except for their coefficient. Okay, so this has coefficient of 3, this has coefficient of what? 1. That's an invisible coefficient, isn't it? So remember. But look, we have xyz, this says yxz. They don't look exactly like, but what do we know about multiplication class? It has a nice property called commutative, right? Therefore, is it possible to rewrite yxz as xyz, right? So because you could do that, they are like terms, even though they don't look exactly like, because there is a commutative property of multiplication, right? Even though if it's not written in the same order, right? That's okay. But should you write it this way or should you rewrite it as xyz when you're doing a problem? xyz. And why should you write it with xyz, not yxz? Yes.
It has to be in the alphabet.
Yeah, you should write them in alphabetical order. Does that make sense? So please note that these two terms are like terms, even though they may not look exactly like, right? Because you could switch them around. What about this one here? 3x squared y cubed z, and I got negative 7 x squared y cubed z. Are they like terms?
Yeah.
Yes, they're all examples of like terms. Okay. Any questions? Okay. They look exactly like, don't they? Okay. So this one, you should think of it as, let me actually write this down here. So this, you should think of it as 3xyz, and we should write this as xyz, right? They're equivalent, right? yxz is same as xyz, isn't that right? Okay, they have the same value. Okay, so write that down. So why do we talk about all these like terms? What's the point? Well, what do we do usually with the like terms? You combine them and so forth, right? So let's see whether you could fill this blank. A polynomial is simplified because I'm going to ask you to simplify polynomials, okay? So I'm going to tell you what it means for a polynomial to be simplified. A polynomial is simplified or in simplest form, same thing. When? Can somebody finish up the sentence? Does anybody know? A polynomial is simplified or in simplest form when what? When what? When you combine like term. Kind of. Good. Okay, almost. When you guys have the right idea. When no two of its terms are similar. In other words, it's kind of like when you got to combine all the like terms, right? Therefore, at the end, when you simplify, there shouldn't be any terms that are like. That's basically what it's saying. You guys, so you have the right idea. So you're right. A polynomial is simplified, or in simplest form, when no two of its terms are similar or like terms. Okay. Any question? Does that make sense? So guess what we're going to ask you to do now?
Adam, see for you.
We're going to do some example that, I'm going to ask you to simplify some fractions. You ready? Anybody need more time? You see people still writing? Okay, I'll give you some more time. Here's example 1. It says simplify negative 3x squared plus 5x minus 2x plus x squared minus 4. So write that down. Okay, so write it down. By the way, isn't this already simplified? No, it's not. You're right. Because you see some like terms. Right? So before I do anything, let's do this one together. So I give you some, sort of way to, because I don't want you to make silly mistakes. Because once you make one silly mistake, the whole thing is wrong, right? So in order to eliminate some of these silly mistakes, do I like subtractions, guys? No. Okay. So can somebody then tell me to rewrite this so that everything's addition? Chris. Good. Plus negative 2x plus. Exactly. So I want you to rewrite everything in addition, because once you do that, once you write everything in addition, addition has a nice property. What kind of property does it have? Yes, sir. Commutative property and also associative property, doesn't it? So does subtraction have that property? No. So once you change everything to addition, you can rearrange the order, and you could associate. You could group them in differently too. Jason, do you know what to do?
I have a question.
Yeah, question.
Do you have to show that step?
Yeah. So please write everything to addition like this. By the way, does anybody see the like terms now? What are my like terms? Angel? Negative 3x squared and x squared are correct. And what do you see any other ones? Carly? 5x and negative 2x. Any other? Do you see any other like terms? What about negative 4? Yeah, it doesn't have any like terms, does it? Okay, so look what I did. You see what I did there? I underlined the two like terms, negative 3x squared and x squared, and I put two lines underneath the two terms that are like, to sort of, so you can see that better. Now I'm going to rearrange them. Anybody know how I'm going to rewrite this? I'm going to use commutative property and also associative property so that I can associate the like terms. Yes, Lindsay.
You could do negative 3x squared plus x squared.
Good.
And plus 5x plus negative 2x plus a negative 4.
Plus negative 4. Don't forget the negative 4, right? Just because it doesn't have any like term, you can't just get rid of it. So do you think, can I associate the two like terms also? Like this? Do you mind if I do that?
Yeah.
Okay, is that okay? And of course, we know the answer, don't we? Okay? So who thinks they know the answer here? So after I do this, look what I did. Many times, people don't write that invisible one and get this wrong. People think that negative 3x squared plus x squared is just negative 3x squared because they don't see any coefficient. But do you see how this is really 1x squared? Okay, so what's the answer? How about Aaron? That's correct. You get negative 2x squared plus 3x plus negative 4. Isn't that right? Now, look what I did, though. I did this. Where did I get that step from? By the way, you don't have to write this step, but I want you to know where I'm getting this from. How did I get that? Where's that coming from? What property am I using here? I got negative 3 plus 1 in parentheses x squared plus 5 plus negative 2 in parentheses x plus negative 4. Where did I get that from? Samira, what do you think? Where is this step coming from? Yeah, I'm using the distributive property backwards. Isn't that right? So when you're gathering the like terms, or when you're simplifying these like terms, isn't that what you're really doing? So you don't have to write that step out, but sometimes it's nice to sort of write it out. Okay, if you're confused. But on your homework, you don't have to write it out. But as you're gathering these like terms, think about what's really happening. Okay, in the back of your mind, you should know that you are using the distributive property backwards. Is that okay? So how many people got this answer? Raise your hand. Okay, at the very end, do you think, could I use the definition of subtraction and rewrite this a little bit more simpler? Who could tell me what to write then? Matthew? So how can I use the definition of subtraction and rewrite this simpler? So instead of writing plus -4, I could just write using the definition of subtraction. Yeah, not -4, -4, right? Does that make sense? You get that? So when you're doing your homework, normally at the very end, of course, when you're simplifying, you want to write as addition, but at the very end, you should write -4 at the end like that, using definition of subtraction. Okay? May I move on?
Yep.
You get the idea? You get the idea? All right. Let's look at example 2 then. Why don't you try this yourself? Okay, I'll give you a minute or two, so it shouldn't take too long. Go ahead. I got 4m squared plus 5mn minus m squared plus 3mn squared. Go ahead, everybody try. All right, how many people, first of all, change it to addition like this? M squared plus 5mn plus -n. Very good. M squared negative m squared plus 3. And then I gather my like terms this way. Okay, there's only 2, right? 4m squared and -m squared. Are there any other like terms? No. Okay, and then like I said, you don't have to write this step. And then how many people got the answer? 3m squared plus 5mn plus 3mn squared. Okay, so normally you write the term with the highest exponent first, okay, and in alphabetical order. So m comes before n, therefore I use the 3m squared first. Any question? Yes. Okay, yeah, you could write 3mn first. Yeah, 3mn squared first and then 5m. Are you talking about the last two terms, switching them over? Yeah, but we'll talk about this later. Once you choose one variable, you choose the highest exponents first, and then the other variable, you write the variable with the highest exponent on the other side. Yeah, that's okay. All right, so we'll learn that a little later. Any question? In other words, last two terms could be switched. That's fine, okay? Because this is m to the first, this is m to the first also, right? Right? But normally, if the other variable, you should write the higher exponent on the other last. So it's sort of opposite of the other. Okay, any question? May I go to example 3? Okay? All right. So if you're going to start with highest exponent for m, you're going to start the highest exponent for n on the right side, the opposite order, if you can. Anyways, that's later. Okay, here's example then 3, okay? So here's example 3. Sometimes they give you these polynomials sort of vertically, and they tell you to add like this. Is it okay if you add vertically? Does it matter? Yeah, it doesn't matter. But you would have to be careful a little bit because look, I got 2a squared plus ab plus 2b and then 4a squared minus 3ab plus 9. Okay, so I could add them vertically, but I should change everything to addition first and line them up so that what? Anybody? See? How should I line them up? Vertically. Yes?
So line them up with the similar terms.
Yeah, line them up with the like term for similar term. Does that make sense? So, well, first two terms, they're fine, right? They're lined up. What about these two, AB and 3AB? Are they lined up correctly? What about the last term? No, so how should I line them up? Dana? Yeah, you could put plus 0 or just kind of leave a space. Yeah, you're right. I could do plus 0. That's a good idea. Is that okay? Can I do that? Because I know that this term has nothing in it, right? So I want to line them up. And do you see how I change everything to addition? You see my subtraction here? I change it to plus negative 3ab, right? Sometimes it's sort of easy when they give it to you vertically, right? Because many times things will line up like this, okay? Go ahead, add them together, see what you get. Oh, wait. How many people, again, you don't have to write this step, but it's nice, okay, if you ever get confused. How many people got this? 6a squared minus 2ab plus 2b plus 9. Raise your hand. Any question? Are we good? We good? Okay, one more. Okay, here we go. It says subtract the lower polynomial from the upper, right? Now, if I give it to you this way, can I subtract as it is? No. It means first I change everything to addition. It means you should subtract the whole thing on the bottom, right? Aren't you subtracting the whole bottom polynomial? Okay, so what should you do with this subtraction? This becomes, yeah, you have to distribute the negative how many times? How many times? Watch this, guys. Okay, 3 times. Give me just a sec. Okay, so look, I changed that subtraction. Do you think I need a parenthesis around this on the bottom? So this becomes plus negative 1 times the trinomial, right? And when I distribute this negative, I get opposite of everything I had. Then you should add them together this way. Does that make sense? And then you get answer as 2p plus 6q minus 12. Any question? Do you understand? When I say to subtract the top one minus the bottom one, you got to put the parentheses around the whole bottom one and distribute the negative all the way.
Is it always on the bottom one?
Well, it depends on what they give you. Does this make sense? Yeah. Okay, thank you.